Hello everyone and welcome. We're going to be looking at the 7.1 Quizizz activity together. So you can see I have question 1 pulled up and we're going to be looking at finding the GCF and then also factoring trinomials. So this first one is looking for the GCF of 12 and 18. Now, some ways that you can figure this out is listing all the numbers that multiply to 12. 1 times 12, 2 times 6, and 3 times 4. So these are all of our factors of 12. And then if we start looking at 18, 1 times 18, 2 times 9, 3 times 6, and then the common factors, so 2 goes into both of these numbers, 3 goes into both of them, and also 6. So the biggest number out of those factors of 2, 3, and 6 is going to be 6. So that's our greatest common factor. There's no x's, so we're just looking at numbers here, 12 and 18. Beautiful. So go ahead and select that and we'll go to the next slide. Question 2, what is the GCF of 3x squared minus 2x? So we can first just think about 3 and 2. Now these are both prime numbers, so 3 is just 1 times 3 and 2 is 1 times 2. So the greatest factor is actually just a 1. So that's not going to change anything. We do have, for the first term, we have an x squared, which is x times x. And then for the second term, we just have an x, which is just x. So the most that they have in common is 1x. So we can factor out an x, and we would be left with 3x minus 2. So our GCF here is x. Go ahead, click x. And we'll go to number 3. What is the GCF of 5x squared plus 20x? So 5 is prime. It's only 1 times 5. 20, we can do 1 times 20, 10 times 2, 4 times 5. So we see 1 and 5 are both common factors. So our greatest common factor is a 5. And then we have an x squared, which is 2 x's, and an x, which is just 1x. So we can also factor out 1x. So there's our GCF of 5x. And when we factor it out, 5x squared divided by 5x is just x, plus 20x divided by 5x is 4. So that would be the factored version. But it's just looking for the GCF here, which is 5x. Beautiful. Question 4. Now we're going to start factoring. So we have an x squared and minus 5x. So x squared is x times x. X is just x. So we can only factor away 1x. X squared divided by x is just x. And negative 5x divided by x is minus 5. So we have x times x minus 5. And remember, you can always distribute. That would get us x squared, and that would get us a negative 5x. So you can always distribute to check that it is the same. Beautiful. Factor 10x plus 15. So we have a 10, which is 1 times 10 or 2 times 5. And then we have a 15, which is 1 times 15 or 3 times 5. So our greatest common factor is a 5. This term the 15 does not have an x, so we cannot factor out an x. So we can only factor out a 5. 10x divided by 5 is 2x. And 15 divided by 5 is 3. So we have 5 times 2x plus 3. Beautiful. Go ahead and select that. And we're a quarter of the way done. Number 6. What is the GCF of 2x squared minus 5x plus 8? So first just look at the numbers. 2 is 1 times 2. 4 is 1 times 2. Sorry. Whoopsies. 1 times 4, or 2 times 2. And 8 is 1 times 8, or 2 times 4. Now, to be a greatest common factor, it has to be a factor of all 3 terms. So 2 goes into all of these numbers, so we can definitely pull a 2 out. We have an x squared and x, but here there's no x, so we cannot pull an x out. So our GCF is just 2, because we have to be able to factor it out of every single term. So I'm going to check 2. Beautiful. Question 7, factor using GCF. We have 8n cubed plus 2n squared. Well, 2, of course, is 1 times 2. 8 is 1 times 8, and 2 times 4. So our GCF of our numbers is 2. Then we have an n cubed. And remember, that means n times n times n. 3 of them. And then we have an n squared, which is n times n. So we can pull 2 out from each, which means we can factor out an n squared. 8n cubed divided by 2n squared. 8 divided by 2 is 4. N cubed divided by n squared. Remember, we subtract those exponents. 3 minus 2 is an n to the first. Plus 2n squared divided by 2n squared is just 1. So we have 2n squared times 4n plus 1. Beautiful. Hopefully we're getting a bit more confident and practice with it. Y'all are rocking it. 10x squared plus 15x and 5. So 5 is just 1 times 5. 10, 1 times 10 and 2 times 5. And 15 is 1 times 15 and 3 times 5. So the greatest common factor we can definitely take out is a 5. Can we take out any x's? So we have an x squared, we have an x, and then there's no x in that last term. So we can only take out a 5. And when we divide everything by 5, we get 2x squared plus 3x minus 1. 2x squared plus 3x minus 1, which is this first one in the left corner there. Beautiful. Alrighty, continuing to factor. 3, looking at our numbers first, is 1 times 3. 9 is 1 times 9 and 3 times 3. And then 15, 1 times 15 and 3 times 5. You don't have to write these out every time like I am doing. If it helps your brain, go, by all means, please do it. If you're able to see what the GCF is without doing that, that's totally fine. So we have an x cubed, which is 3 x's. We have an x squared, which is 2, and then we just have an x. So the most we can take from every group is 1. So we have 3x. 3x cubed divided by 3x is going to be x squared, plus 9x squared divided by 3x is 3x, and 15x divided by 3x is 5. So we took out a 3x, we have x squared plus 3x minus 5. Brilliant. Perfect. Question 10. 2n squared plus 16n plus 12. So we're looking for that GCF to factor out. We notice that the last term does not have an n, so we're only going to be factoring out a number. The only numbers that go into 2 are 1 and 2. So we can, 2 goes into 16 and 2 goes into 12. So we can factor out a 2, and then we're left with n squared plus 8n plus 6. And again, just remember when we factor out that GCF, we're just dividing every term by 2. We're doing like reverse distribution. So there's our answer for number 10, making us officially halfway through. Okay, so the second part of this Quizizz is factoring the trinomial when a is equal to 1. So we want to find two numbers that multiply to our c value and add to our b. So in this case, our c is 63. Get this right here. And our b is 16. So it helps to know your times table for sure for these ones. I know that 9 times 7 is 63. And 9 plus 7 is 16. So those are going to work for us. They're both positive. So we have n plus 7 times n plus 9. So we got that positive 7 and that positive 9. Beautiful. Let me clean this up and get our new values. So for this one, we want to multiply to c, which in this case is 20. And we're going to add to b, which here is 9. So numbers that multiply to 20, 1 times 20, 2 times 10, 4 times 5. And then we look at these numbers, which one of them can like add to 9 or has a difference of 9. And we see that with 4 and 5, right? And they're both positive. 4 times 5 is 20, 4 plus 5 is 9. So that's going to fit our criteria here. So you can plug in that first one. Beautiful. Okay. Question 13. Our C value here is 45 and our B value is 18. Ooh, I know 5 times 9 is 45, but when you add those you get 14. So that's not going to work. Looking at my options, 6 times 3, that gets us 18, so that's not working. We want to multiply to 45. 15 times 3 is 45, and 15 plus 3 is 18, so that'll work. So it's kind of nice to have the options to see how we're finding these numbers. If you don't know your times tables, that can definitely support you. Beautiful. Let me erase our board here. Okay, so we want to multiply to 60 and we want to add to a negative 16. Make sure to take that sign with you. If it's negative, we got to grab it. So looking at our options, we have negative 15 and 4. So negative 15 times 4 does get us a negative 60 when we multiply them. We want a positive 60, so that's not going to work. This one is a negative 6 and a positive 10. So negative 6 times 10 also gets us a negative 60. That's not going to work. This is a negative 6 and a negative 10. So negative 6 times negative 10 is a positive 60. So far, that's good. Negative 6 plus negative 10 is a negative 16, which is also what we want. Aha! So this is going to be our option because we want to multiply to a positive and add to a negative. After this one, I am going to pause the video and we're going to come back for part 2 for the last 6 problems, okay? So I'm going to pause the video here. See you in part 2.